In the vast cosmos with its mysterious universe, the Earth where humanity resides is as tiny as a speck of dust. Thus, we have reason to believe that humanity is not alone in the cosmic universe. We can even reasonably speculate that the universe likely contains advanced civilizations that emerged earlier and are more technologically advanced than humanity, although we currently lack definitive evidence to prove this speculation. However, according to existing stellar observation data, at least 3 signs indicate that advanced civilizations far more advanced than humanity may actually exist. First, stars with spectral anomalies. The physicist Carl Sagan once conjectured that if extraterrestrial civilizations truly exist in the universe, they likely also hope to find other intelligent civilizations in the cosmos like humanity does. If they cannot find any, they may massively inject substances that should not naturally exist on stars into nearby stars, hoping to attract the attention of other intelligent civilizations to make contact. Interestingly, in the direction of Sagittarius, 355 light-years away from us, there's a star called HD1N1N65. Spectral analysis shows that this star contains detectable actinide elements that should not naturally exist on stars. Why? For 2 reasons. First, actinide elements are rare heavy elements that cannot be produced through nuclear fusion inside stars, only generated in high-energy events like supernovae and neutron star collisions, so their abundance in the cosmos is extremely low. Second, actinide elements are radioactive, and many have relatively short half-lives. Therefore, theoretically, the proportion of actinide elements in stellar matter should be extremely low, and basically cannot be detected in spectra. So where did the actinide elements in HD1N1N65 come from? Perhaps we can speculate that this may be evidence of an advanced civilization massively injecting actinide elements into this star to demonstrate their existence in the cosmos. Second, stars occluded by gigantic objects. From the development history of human civilization, we can see that the higher the technological level, the greater the energy consumption. In our solar system, the Sun accounts for about 99.86% of the total mass, making other celestial bodies insignificant by comparison. Thus, a reasonable inference is that if human civilization develops to a certain level in the future, we may directly use the Sun as an energy source and massively extract energy from it. This inference also applies to other possible intelligent civilizations in the cosmos. Perhaps we can posit that the advanced civilizations in the cosmos are already doing this. So how do they massively extract energy from stars? Regarding this, the physicist Freeman Dyson conjectured that advanced civilizations may build giant energy collection devices around stars. As early as 2009, people noticed that in the direction of Cygnus, about 1480 light-years away from us, there is a star called Chi-C 8462852 that would dim drastically in a short period of time before recovering to normal. Later continuous observation by the Kepler Space Telescope showed that the brightness of Chi-C 8462852 does indeed decrease to varying degrees at different times, with a maximum drop of 22%. In the following period, scientists successively discovered another 21 stars, similar to KTEC 8462852, 15 of them called slow variators, with frequency and amplitude of brightness change similar to KIC 8462852, and the other 6 called fast variators, with more frequent and drastic brightness changes. In particular, in the direction of Scorpius, about 460 light-years away from us, there is a star called Epic 2042789116, whose brightness plunged drastically multiple times within just 78 days, with a maximum drop of around 65%. Since such brightness variations are difficult to explain through natural phenomena, some have speculated that gigantic structures built by advanced civilizations may exist near these stars, occluding them and causing such brightness changes. Third, mysteriously vanished stars. In the direction of Aquarius, about 75 million light-years away, there was a star called PHL 293b LM1 in a dwarf galaxy called PHL 293b. Its mass was about 85 times that of the Sun, and it was a rare, highly luminous blue variable star, whose maximum luminosity could reach 2.5 million times that of the Sun. Because of this high luminosity, we could directly observe it from such a huge distance of 75 million light-years. Observation data showed that PHL 293b LM1 existed steadily from 2001 to 2011, but then this star suddenly vanished after that. Notably, PHL 293b LM1 was not an isolated case. This brings us to the vanishing and appearing sources during a century of observations, VASCO project. which started in 2017 and simply compares astronomical observation data from different periods to look for anomalies. In 2019, VASCO pointed out in a research report that over 100 stars have mysteriously vanished since the 1950s. As research continued, the number of such mysteriously missing stars kept increasing, reaching 798 so far. Theoretically, no matter what kind of star, it is impossible for it to suddenly vanish, because after the fuel in the core nuclear fusion zone of a star is exhausted, low-mass stars will gradually die out over a long period, intermediate-mass stars will expand into red giants, and high-mass stars usually end with powerful supernovae whose peak luminosity can rival that of a galaxy-scale system like the Milky Way. Perhaps we can speculate that these mysteriously vanished stars may be related to advanced civilizations far more advanced than humanity may have built, gigantic energy collection devices capable of completely enveloping entire stars, or may have even found ways to rapidly extract much of the stellar material, essentially packing up stars in a short time.